All right, so we're looking at the 3.0 level for exponent rules. And so we have the same 5 that we learned in the 2.0 level. And the 3.0 level will just be able to use multiple rules in the same problem. So we're going to go ahead and fill this table in. So the first one is our 0 rule. Anything that has a power of 0 is 1. And so we can do that. So in our example, we have some parentheses with a squared, b cubed, and c, and that's all being raised to a power of 0. The 0 has power over everything in the parentheses, which is actually everything in the problem, so all of that turns into 1. For our second rule, we have the negative rule. For this one, whenever we have a negative exponent, we have to move it so it turns positive. So if it's in the top and it's negative, we have to move it to the bottom of the fraction. If it's in the bottom of the fraction and it's negative, we have to move it to the top. So for the rule, this would become 1 over x to a positive m, because when we moved it into the denominator, it turns positive. So in our example, we're going to do piece by piece. So the first part here is 4 to the negative 1. That has to be moved into the denominator. So when we move it into the denominator, it has a positive 1 exponent, which we don't have to write the positive 1 exponent, so we just leave it as 4. And I'm going to cross that out. The next part says x to the negative 5th. So for x to the negative 5th, we also need to move that because it's a negative exponent. And so that also has to get moved to the bottom. When we move it, it turns into a positive exponent. The last part is the y to the 3rd. That already has a positive exponent, so it can stay right where it's at on the top. So we have y to the 3rd on the top and then 4x to the 5th on the bottom. We can't combine two different variables, so that would be our final answer. Our next rule is the product rule. For this one, whenever variables are being squished together, they're being multiplied. So for our exponents, we have to add them. So we keep the same base and we're going to add our exponents. So in the example, it's a little different because we have coefficients. For the coefficients, they are not exponents. So we are going to multiply the 2 and the 4. When we multiply 2 and 4, we get 8. And then we can look at our r. So we have r to the negative 6th and r to the 4th. We want to add our exponents. Negative 6 plus 4 is negative 2. And then one thing that we should notice here is we have a negative exponent, which we don't want. And so that negative exponent is only on our variable r. So that needs to get moved into the denominator. And so we keep the 8 on top and we move our squared to the bottom, and it turns into a positive exponent when we move it. And that's our final answer. Our next rule is the quotient rule. So when we divide variables that are the same, we want to subtract our exponents, and we always subtract the top minus the bottom. In our example, we have a few steps that we want to do. So the first thing is we have some coefficients in front. So we're going to deal with the coefficients like we did in the previous example, but this time because they're in a fraction, we are going to divide them. So we have 10 over 5. 10 divided by 5 is 2. So we make that a 2. And then moving next to it, we have a cubed and a squared. And then we also have an a in the denominator. So a cubed and a squared are next to each other, so we want to add those exponents. That would give us 8 to the 5th. And then we can subtract the negative 1 from the bottom. So we have 3 plus 2, which is 5, and then minus a negative 1, which would give us 8 to the 6th. And then the last part is these b's. The b on the top doesn't have an exponent, which means there's an invisible 1 exponent. And so we can subtract those. So we do the top minus the bottom. So 1 minus 5 would be negative 4. So we have 2a to the 6th, b to the negative 4th. Now looking at this, we do have a negative exponent, which we don't want. And so to fix it, we can move that to the denominator, but only the b with the exponent. So we keep the 2a to the 6th on the top, and we move b to the 4th into the denominator. And the 4 turns positive. The last one is our power rule. With these exponents, we just multiply them. So we do m times n. In the example, the first thing we want to do is make sure everything has an exponent. And if there's not an exponent, we should write in the invisible 1 that we know is there. So our coefficient of 3 does have a 1 exponent. We have x cubed, y to the negative first, and z to the negative first. And all of that is being brought to a power of 3. So that power of 3 gets applied to every single piece of this. So to the coefficient, and then to the x, the y, and the z. And so we can multiply our exponents. So we're going to have 3, and our exponent 1 times 3 is 3. We have x, and then we multiply our exponents, so we get 9, so x to the 9th, y to the negative 3rd, and z to the negative 3rd. Looking at this, we can simplify a couple things. 3 to the 3rd is 27, and we keep that in the top. X to the 9th stays right where it's at because it's a positive exponent. Our y and our z both have negative exponents, so we want to move both of those into our denominator. And so that's our final answer, 27x to the 9th over y cubed, z cubed. Right below, there is an example that we're going to go through. Let's move over here. So for this, it is a little different because if we look at the parentheses, the parentheses around the entire fraction, which means the exponent of 3 goes to both the top and the bottom. And so the first thing that we should do is look to see if there's an exponent of 0 and get rid of those first because it'll make it easier for us. So we're going to cross out y and z because they both have an exponent of 0. And then we can distribute that exponent to everything and use our power to power rule. And so I'm going to start at the top. So we're going to have 3 to the 3rd, x to the 9th, y to the negative 3rd, z to the negative 3rd, over x to the negative 12th. Because we still multiply the 1 in the denominator because it's inside the parentheses. And so from here, we can simplify a couple things. The first thing is I'm going to simplify our 3 to the 3rd, which is going to be 27. Next, we have a couple x's. So we have x to the 9th on the top and x to the negative 12th on the bottom. That is our quotient rule. So we're going to do 9 minus a negative 12, which will give us x to the 21st. Then we can look at our y to the negative 3rd. That has a negative exponent, so it needs to get moved to the bottom. And when it moves to the bottom, it turns positive. So we have y to the positive 3rd in the denominator. And then our z to the negative 3rd also needs to get moved into our denominator as well. So our final answer is 27x to the 21st power over y cubed, z cubed. And then when we look at our options, it's going to be option C. And the you guys can do on your own. I'll circle the correct answer for them.